Hello and welcome to this solution video. If you like this video, please share with your friends and subscribe to Math United. Let's get started with question number 1, which says a bag contains 9 blue marbles rather. So let me write it here, 9 blue marbles, 3 red marbles. On one marble is chosen at random from the bag. If this marble is blue, it is replaced back into the bag. If this marble is red, it is not returned to the bag. Okay, so reds will keep on decreasing, but blue will stay the same. That's what they are trying to say. A second marble is now chosen at random from the bag. Find the probability that both the marbles chosen are red. So let's draw a tree diagram first. So first draw, this is first draw. We'll get either blue or red marble. Okay, the probability in first draw is 9 plus 3, 12. So for blue it will be 9 out of 12, and here it will be 3 out of 12. Okay, now second draw, it will be 2 possibilities again from each previous outcome. Now they've said that if the marble is blue, it is replaced. So blue will go back, so it will still remain 9 out of 12, and this will still remain 3 out of 12. But if it was a red, it is not returned to the bag. That means this one is red, so blue will stay the same because the first one was red, so it will remain 9 but out of 11 now, because the first one was red, it was not replaced, so total number of marbles now are 11. And obviously this will be 2 out of 11 because one red is out, so only 2 reds are remaining. 2 out of 11 will be the probability of red. Now the main question says find the probability that both the marbles chosen are red. So where are they red and red? Here in this branch they are red. There is no other branch where that is red. Both of them are red. So we can write probability that both are red will be this first one, 3 over 12 multiplied by 2 over 11, second one, and that will be 6, 2, so 1 out of 22. This is the probability that both the marbles drawn are red. Moving on to the next part, find the probability that the first marble chosen is blue given that the second marble chosen is red. Okay, so let's name them. First marble chosen is blue. Let's call it event A. Second marble chosen is red. Let's call it event B. So we have to find probability of A given that B happened. Okay, according to conditional probability, it will be equal to A intersection B, that both the events happened, divided by the condition, the probability of condition. So probability of A intersection B divided by probability of B. Yeah, this is what we do. So first probability of B, that second marble chosen is red. Second marble chosen is red. What is the probability? Either this is the case or this is the case. In both cases, the second marble chosen is red. So let me find PB first. So it is either this branch or this branch, one of these two. So what will I do? I will just multiply their probabilities. So it will be the second one is red, so 9 over 12 multiplied by 3 over 12. Either this will happen, or when we say or, because both the branches cannot happen, they are options of each other. Second one will be 3 out of 12. First one is red and second one is red again. Okay, this is the probability of B. Okay, so can we simplify this? All right, 9 and 12 can cancel. 3, 4, 1, 4, that becomes 3 out of 16. Plus, and this will be 6, 2, so 1 out of 22. Okay, this we found in previous part also. All right, so let's add this one. By the time I find it out with my calculator, I would request you to like this video again, share with your friends. That'll motivate me to make many more videos, and please subscribe to Math United. What I'm getting is 41 over 176. Now, going back to the tree diagram, we have to see which branch out of this has first marble chosen is blue, which is this one. This is not the one. And second marble chosen is red, which is this. So 9 over 12 times 3 over 12, which we got already here. 9 over 12 times 3 over 12 is 3 over 16. So this becomes our denominator. So our answer, if we can continue here, will be 41 out of 176. This is the denominator which we got here. And numerator will be 3 out of 16, which we got in the process to get this. And now we can write it this as 3 over 16 divided by 41 over 176, and then 3 over 16 multiplied by 176 over 41. This gives us 11. So 33 out of 41. This is our probability that the first chosen marble is blue, given that second one is red. Question number 2 says Sam is a member of a soccer club. She is practicing scoring goals. The probability that Sam will score a goal on any attempt is 0.7, independently of all other attempts. That means every time she tries, there is 70% chance that she will score a goal. Part A. Sam makes 10 attempts at scoring goals. Find the probability that Sam will score goals on fewer than 8 of these attempts. That means probability, if we take the variable as x, it is fewer than 8. What does that mean? It is either no goal will be scored or only one goal will be scored out of 10 attempts, right? Or 2 or 3, or last one will be probability that x is equal to 7. So probability of 0, 1 and till x to the power 7, because they said fewer than 8, that means 8 is not part of it. So there will be how many? There will be 8 of them. In place of doing these 8, what we can do, we can subtract the ones which are missing. So probability that he scores 8 goals out of 10, or he scores 9 goals, or he scores all of the 10 goals. We will find the probability of these 3 and subtract from 1. So because these 3 will be excluded, so we'll get these 8, the ones we want here. So it's better to find 3 than finding 8. And what will we use? We use binomial probability, because the conditions for binomial probability are met. What? There are fixed number of attempts which are 10. So first condition is met. The probability is independent of each other. That's second condition. Third condition is that the probability should be constant, which is also met. And third, there should be only success and failure, which is also met. How? Either the goal will happen or goal will not happen. There are just 2 possibilities. So all 4 conditions met, we can use binomial probability in this one. So for that, we'll keep 1 minus like this, and we'll interpret this into binomial. For that, what do? Our formula for that is NCR P to the power R Q to the power N minus R. This is the probability of each part. So n is the total number of attempts, which is 10. So we'll write 10 C, and number of success is R, which is 8 in this case. Then we have P. P is the probability of success, which is 0.7. That will score again, right? Find the probability, will score again, and will score. So that they're talking about success only. 0. And that means the failure or rest of the two attempts, she fails. And what is the value of Q then? Q is always 1 minus P, which is 1 minus 0.7 or 0.3. So we got probability of failure 0.3, that we'll keep here. Next, 10C, 9 this time. Successes 9, failures 1. 9 plus 1, 10. Total events 10. 10C, 10, that means all of them successes. 0.7 to the power 10. 0.3 to the power 0, which is 1, so no need to write it. So this is what we will subtract. We'll carefully put this in our calculator and we'll get the answer. By the time I do this, I would request you to like this video, share this with your friends, and subscribe to Math United. It will motivate me to make many more videos like this in the future. I think I'm the first person on YouTube to make this solution video and serve you. Thank you. What I'm getting here is 0.617217. So 3 significant figures, I can write it as 0.617. That's it. Okay, let's go to part B. Find the probability that Sam's first successful attempt will be before her 5th attempt. It means that she will get her success for sure in first 4 attempts. Okay, before her 5th attempt means she will be successful within first 4. Which one we don't know, but what we are sure that she will not fail 4 times. This is Q is failure, right? So 4 times if she fails, that will be Q to the power 4, but that will not be the case. Okay, so if that is not be the case, we'll subtract it from 1. So it will be 1 minus Q was 0.3 to the power 4. So which will be how much? 1 minus 0.0081, yeah, 0081, and that will be how much? 19. So 0.9919, or if we do it for 3 significant figures, it will become 0.992. Let's move on to the next part, which is C. Wei is a member of same soccer club. He is also participating scoring goals. The probability that Wei scores a goal on any attempt is 0.6, less than Sam, independently of all other attempts. Alright. Wei is going to keep making attempts until he scores 3 goals. Okay. Find the probability that he scores his 3rd goal on his 7th attempt. So the probability of success for Wei is 0.6, and the probability of failure is 0.1 minus 0.6, which is 0.4. We want a success on the 7th attempt. That means 1, 2, 3, 4, 5, 6, and this is the 7th. And it is surely to be 0.6. Now this should be the 3rd attempt, 3rd successful attempt. That means before this we should get 2 successes, which will be out of 6, any 2 will be successes, and the probability of them is 0.6 to the power 2. That means rest of the 4 are failures. Okay, so our probability that 3rd success or 3rd goal we can write on 7th attempt will be 6C2 times 0.6 to the power 3 now, because this will also be multiplied. We already have 2 of them, and then 0.4 4. Let's put this in a calculator and we'll see. By the time I do this, I'll request you to like this video, share with your friends, and subscribe to Math United. What I'm getting here is 0.082944, which can be rounded off to 0.0829. Question number 3. It says the time taken in minutes by 150 students to complete a puzzle are summarized. Some 8 students completed within 20 minutes, 23 took 20 to 30 minutes, and so on. 12 of them took 50 to 70 minutes. Okay, what do we need to do? Draw a histogram to represent this information. Okay, so let's say the class size is, how much is the class size here? 20. 0 to 20 is 20, but this is just 10. This one is 5. So our class sizes, class intervals are uneven, so we should depend on frequency density in that case. Okay, what is frequency density? The frequency we have 8 divided by the class width. What is the interval? So it is 20. 0 to 20 is 20, so we'll divide by 20, which is 0.4. Similarly here, 23 divided by 10. Yeah, it is 10 only, so it will be 2.3. 35 divided by 5, 7. 52 divided by 5 again. Isn't it 5? Yes, it is 5. So 52 divided by 5 will be 10.4. 20 divided by 10 will be 2. 12 divided by 20, isn't it? 50 to 70, 20, so 0.6. So we got our frequency densities, and in our histogram, that's what we will do. We will use frequency density on the vertical axis, and time taken will be on the x-axis. So let me minimize so that we can see it clearly. Okay. So I will fast forward this video. I will add scales to it and draw the histogram and explain to you later on. So this concludes our histogram. The lowest frequency is 0.4 here, and the highest one is 10.4. This one between 35 and 40. 35 and 40. This gives us the highest bar. The bars are connected to each other. That is the essence of histogram. The scales are starting from 0, and their scale is uniform. It is not according to the scale here. It is an independent uniform scale in both vertical and horizontal axis. I hope you understood how to find this. Calculate an estimate for the mean time for these students to complete the puzzle. As then in C part also there is one. So we'll need to copy this in a vertical format for rest of it. So let me do this hurriedly. Okay, so I got this answer, mean 35.8, which is in between, so it makes sense. What did I do? I found the mid value of each group from 0 to 20. I added 0 and 20 divided by 2 is 10. 20 plus 30 divided by 2 will be 25. So these are the numbers which are the mean of the two ends of the group. And then I multiplied that mid value, which is x, with the frequency. So 10 times 8 is 80. 25 times 23 is 575, and on. And then I did it for all of them. Then this is the formula for the mean. Sigma fx over sigma f. Sigma f means addition of all the frequencies. It is 150. It is given in the question. And sigma fx, the sum of all the fx's. So I added all of them. I got 5362.5. And when we divide, we got this mean. Okay, let's go to the next one. Calculate and estimate for the mean done. In which class interval does the lower quartile of the times lie? Since they are asking only the class interval, so no need to go to cumulative frequency graph and all. We will just see where is the lower quartile. Lower quartile is 1/4 of the sigma f, the total frequency, which will be 1/4 of 150, which is 37.5. So where is the 37.5th item in this, in which interval it is lying? So we can see 8 are here, 8 plus 23, 31 are in these two. So that means 32nd onwards will be here in this one, and 37.5 will be in this group, 30 to 35, and that's what we can write here as an answer. On in which class interval does the lower quartile of the times lie? It is 30 to 35, right? Cosine is here, not here. So this is the answer. Question 4. A company sells small and large bags of rice. The masses of the small bag of rice are normally distributed with mean of 120 kg, 1.20 kg and standard deviation of this in a random sample of 500 bags of these small bags of rice. How many would you expect to have mass greater than 1.26? So they are normally distributed, so let's try to visualize that. This is our normal distribution graph. Mean at the middle is 1.2. We want greater than 1.26, so let's say 1.26 is here, 26. So we want this probability greater than 1.26. Okay, for that I have the table here which is provided in exams, and for that using this table we need the z-score. So probability that x is less than, because our table is about less than only, so less than 1.26 will be let's start with z-score, not probability straight away. So let me find the z-score. Will be the x, whatever it is, minus mean divided by standard deviation. X in this case we've already taken 1.26, and minus mean is 1.20 divided by standard deviation, which is 0.16. So it will be 0.06 divided by 0.16. Let's see how much this is. 0.375. This is what we're getting the z-score as. So the probability that z-score is less than 0.375 is here. 0.3 is here, 7 is here, 6443, and 5 in this line is 19. So 19 plus 43, last two digits of this will give us 62. 0.6462. Okay, so it will be 0.644, not 4, 6462. 0.6462 is this area, right? But the question was greater than, so probability that z is greater than 0.375 will be 1 minus 0.6462, because the sum of all the probabilities in this is 1. From that we will subtract this dotted one and we'll get the shaded one. So how much will that be? 8, 3, 5, 3, 0.3538. Okay, and then they are asking how many would you expect to have mass greater than 1.26 kg. So this is the probability of being greater than 1.26. So we'll just multiply by 500. Out of this, the probability is 0.3538, and we'll get those number of bags. It comes out to be 176.9 or 177 bags. Okay, the masses of large bags now. They were small bags. Large bags of rice are normally distributed with mean of 2.5 kg. Okay, so the mean here is 2.5 kg. And the standard deviation mu. 20% of these large bags of rice have a mass less than 2.4. So let's say 2.4 is here, and this is a 20% area, which is 0.2 probability. So my plan would be that I will reflect this here, because the table I have just shown you is not applicable for negative z-score. We'll get negative z-score here. So we'll convert that to positive z-score here. How? If this is 0.2, we know that the area below this will be 0.8. This whole area till here will be 0.8. From 0.8, we'll get the z-score for this one, which will be exactly same z-score at this place but negative. Okay, so let's start with 0.8, because our table is only for less than. So from this line, 0.8 area is less. So what will be the z-score for 0.8? So probabilities in this table. Let's look for 0.8. 0.7995 we have here. Yeah, let me write here. It will be 0.8, 0.8 this one, and 4, and we need 5 more. So 5 is here. 5 is will be at 2. So 0.842 is the z-score corresponding to 0.8 probability, which is below this one. So z-score here is 0.842. So the z-score here will be negative 0.842, because they are equally distant from mean, and that's what I will use here. Z for a new variable, let's say y, is less than 2.4 is our specific value, will be is equal to, we got it, we already have it now, minus 0.842, minus 0.842, which will be, according to formula, the data, which is 2.4, minus mean, which is 2.5, divided by sigma, which is unknown. And now we can find sigma by cross multiplication, which will be 2.4 minus 2.5 will be negative 0.1 over negative 0.842. So these negatives will cancel out, and let's see what do we get after dividing 0.1 by 0.842. 0.842. We get 0.118, which we can 1187. So we're 119. We can write it is 0.119, significant figures. Do we have a C part also? Yes. A random sample of 80 large bags of rice is chosen. 80. Big number. Use a suitable approximation to find the probability that the fewer than 22 of these large bags of rice have a mass less than 2.4 kg. So they are again large, again 2.4 kg. That means the probability of success getting this will be 0. How much we got? 8, 0.1. No, that was sigma. Our probability was this thing less than 2.4, right? So it was 0.2. So the probability of success in this case is 0.2. So the probability of failure will be 1 minus 0.2, which is 0.8. Okay. Now they are asking us suitable approximation, and what approximation is better than normal distribution. But for normal distribution, we need first a test. NP should be greater than 5 and NQ also should be greater than 5. So let's test it here first. N is how much? How many total bags? 80 large bags. So 80. Probability is 0.2 of success. So we get 16 more than 5. Very good. 80 times 0.8, of course it will be 64 more than 5 again. So we can use normal approximation. Our mean is NP. So our mean is NP, which is in this case is 16. We just got a 16. NP. Okay. And fewer than 22. So our number here is 22. We want fewer than. So very good. Our z-score table is always less than 22. So no problem. Z-score for, let's say, mass, let's say M. I've used X variable, I've used Y, so I'm using M variable this time, is less than 22, but one twist here. This is fewer than 22. That means 22 is not part of it. So what will we do? We will take a number which is less than 22, but more than 21, which will be 21.5. So if I say less than 21.5, that will include 21, but that will not include 22. So I will undo this. And write 21.5 here rather. Z-score of 21.5. So 21.5 minus, and then what is the mean? 16. Divided by, what is the standard deviation? Standard deviation is square root NPQ. So let me put it here. 80 times P 0.2 times Q 0.8. Let's see what z-score it gives us. By the time I do this, I would request you to like this video, share with your friends, and subscribe to Math United. It will motivate me to make many more videos like this. What I'm getting here is 1.537. This is what I'm getting. So let me look for 1.537 positive in the table. 1.537. So 1.5 is here. 3 is 9370, and 7 will be 8. Yeah, that's the seventh line. 8. So it will become 9378. 0.9378 is the probability. So let's go here. Probability 0.9378. Probability that M, that was z-score, this probability, okay, 21.5 is equal to 0.9378, or we can round off to 0.938. Question 5. Anil is taking part in a tournament. In each game in this tournament, players are awarded 2 points to win for winning and 1 point for drawing and 0 for loss. For each of Anil's games, the probabilities that he will win, probability of winning is 0.5, probability of draw is 0.3, and probability of losing is 0.2. Okay. Respectively, the results of the game are all independent of each other. The random variable x is the total number of points that Anil scores in his first three games. Okay? Part A. Show that Px equal to 2 is 0.114. That means he scores 2 points. And 2 points can be earned how? Win, lose, lose, because he will earn 2 points for winning, 0 for losing the rest of the 2. So he'll get 2 points. It can be draw, lose. So 1, 1, 0. And 2 is not possible any other way. Okay. So let's interpret this one first. So Anil can win either the first game or second game or third game. We don't know, right? Which one? But what we know that there are 3 possibilities, and the probability of those possibilities of winning one game. What is the winning of one game probability? 0.5. Then losing is 0.2. So 0.2 times 0.2. This is the probability that he wins one game and loses 2. This is the probability. All right. Here, any 2 games we have to draw. Anil has to draw 2 games. So out of 3, he will draw 2 games. And then let's write the probability. The draw probability is 0.3. So again 0.3. And then losing 0.2. So he can draw any 2 of them. Which 2 will be taken care of? This combination. So we have to add these 2 probabilities, because either this will happen or this will happen. Both cannot happen together. So 0.5 times 0.2 will be 0.1, and 0.1 times 0.2 is 0.02 times 3 is 0.06. Okay, and now this one 3C2 will be 3 again. Then we have 0.09 here, and then we'll have 0.018, which is equal to 0.054. So probability x equal to 2 will be equal to 0.06 plus 0.054, which will certainly be 0.114. Okay, B part, complete the probability distribution. So it is already here. X equal to 2, 3, 4 and 6 have been given to you for saving your time. So you just have to fill the 0, 1 and 5. 0 is easy. Let me do it here. So 0 will be that he loses all 3 games, so he'll get no point, right? And the probability of losing is 0.2, 0.2. So it will be 0.2 times 0.2 times 0.2, which will be cubed, which is 0.008. So very less chances that Anil will lose 3 games. Now 1. So 1 point cannot be gotten by winning any game. So there will be no win. Draw is a possibility, and then losing the other 2 games. So this will give 1 point, this will give 0 point, 0 point. But which one? 3C1. Yeah? Multiplied by the probability of draw is 0.3. And then we have 0.2 times 0.2. So that becomes 3 times 0.3 times 0.2 will be 0.06. 0.06 times 2 will be 0.012. So it is 0.036. So 0.036 will be here. And 5 I don't want to calculate, because we know the sum of all of them will be 1. So I will add all of these and subtract from 1. I will get the remaining part. So 0.008 plus 0.036. Then we have 0.114, 0.207, then 0.285, then we don't know this, 0.125. So let's add all of them and subtract from 1. Okay, so I got 0.775, and if I subtract it from 1, I'll get 0.225. I could have used the same logic what I use for others, but this is the easier way out I saw. So I've completed the probability distribution for X. Okay, do we have something else here? Yes, find the value of variance. So variance of X we have to find out, and the formula for that is sigma X square probability of X minus because we have not found any mean in this one, so we will write the mean square. Okay, mean is sigma X px square. This is the formula for variance. So for this I will multiply each X, this which is X, this 0, with the probability 0.08. For each one I will do that. So let me write here X multiplied by px. So here multiply 0 with 0.08, we'll get 0. So I get 0 here. Now 1 times 0.036, 0.036. Okay, then 2 times 0.114 will be 0.228. Then 3 times 0.207 will be 621, 0.621. 4 times 0.285 will be 0.570, and double will be 1.14. Okay, now 5 times 225 will be 5, 5 times 10, 12, 5 times 11, 1.125, and this has to be 0, 5, 7, 0.750. I will add these all and I will replace this one. So I will add 0.036 plus 0.228 plus 0.621 plus 1.14 plus 1.125 plus 0.75 square. Okay. Now for this I'll have to square the X and then multiply with the probability, and this part, because it needs a lot of calculation, so I will fast forward it. So I will make that table here. So here 0 square times this will be 0, so nothing big here. 1 square is again 1, so 0.036 again, and then it will take some time. So what I get here is 17.04 minus 3.9 whole square, which is 17.04 minus 15.21, and finally our variance of X comes out to be 1.8. Question number 6. A new village social club has 10 members, of whom 6 are men and 4 are women. So there are 10 members, 6 are men rather, and 4 are women. The club committee will consist of 5 members. In how many ways can a committee of 5 members can be chosen if it must include at least 2 men and at least 1 woman? So let's make a list for this. At least 2 men. So let's say 2 men. How many women will be needed? 3, and that meets the other case, at least 1 woman. Yes. Now if we have 3 men, how many women? Does that meet the requirement? Yes, 2 women. Total is 5. Then we have 4 men. So how many women needed? 1, and which also meets this. And we can't have 5 men because that will make woman 0, and which is not allowed. Is there any other possibility in this? No. So let's interpret them in combination form. So we need to select any 2 men out of 6. So it will become 6C2. Then we will have 3 women out of 4. So 4C3. Similarly here it will be 6C3 and 4C2. And then we'll have 6C4 and 4C1. Let's evaluate them one by one. 6C2 will be 15. 4C3 will be 4. So that comes out to be 60. 6C3 will be 20. And 4C2 will be 6. That will be 120. 6C4 is same as 6C2, which is 15. And 4C1 will be 4. So 60 again. So it comes out to be 240 different ways we can form such a committee which has at least 2 men and at least 1 woman. Okay. The 10 members of the club stand in a line for a photograph. B part says how many different arrangements are there of the 10 members if all men stand together and all women stand together. So 1, 2, 3, 4, 5, 6. There are 1, 2, 3, 4, 5, 6 men, and then we have 4 women. So here men are together and women are together, but it's also possible that all women are on the left side and men are on the right side. So there are 2 possibilities, right? Now within this group, these 6 men can change their place, so it will be 6 factorial, and 4 women can change their place here, that will be 4 factorial. So the answer should be 2 times 6 factorial is 720, and 4 factorial is 24, which comes out to be 34,560. Such arrangements. Okay. For a second photograph, the members stand in 2 rows with 6 on the back. Okay, 1, 2, 3, 4, 5, 6 on the back and 4 in front. 1, 2, 3, 4. Ollie and his sister Petra are 2 of the members of the club. How many different arrangements are there of 10 members in which Ollie and Petra stand next to each other on the front row? Okay, so first we'll make a box around Ollie and Petra, right? So that whenever they move here, they will move together so that they remain together. So they can be here, or they can be in these 2 seats, or they can be in these 2 seats. These are the 3 possibilities, right? So we will write 3 possibilities in front row. Their box can be arranged, but within that box again they can change the place. O and P, right? Ollie and Petra, they can change their places, so 2 factorial. So we have taken care of their positions. Now once those 2 have occupied their places, we have 6 plus 2, 8 left, and on those 8 places anybody can stand. So we can write 8 factorial in that case. So let's see how much is this equal to. It comes out to be 241,920. These are the number of possibilities that those 2 brothers and sisters are together. That concludes our solution video. I hope you liked it. If you did, please give it a thumbs up and share with your friends and subscribe to Math United. Thank you very much.